ninth CBSE, right? Yes, sir. So, my name is Uday. Yes. The volume 1 G. And I'll be teaching the physics part of your science subjects. Okay. So, what is the? Is this other schools open? So all of you have to wear your ID cards in the class, okay? And are the schools open? So what are they teaching in there? Which topic? They haven't started anything. क्या पढ़ा रहे हैं? Motion is started. Okay. So like I said, I'll be teaching you the physics portion of the science syllabus. So the first chapter is motion of physics. Okay, so that is chapter 7, and that is motion. Right? So everybody is familiar with motion, right? You see it on a daily basis. Something or the other thing, other body is moving. So how do we describe motion? What is motion? When do we say that a body is in motion? So you can try. I mean, be very wrong or right. It's okay, but try.
When it is moving or it is moving.
So when do we say that the body is moving? That's the question.
When the body changes its position.
Yes. So in science, we have to technically define things. So there is something called as position. So position is like every point has got a fixed position. Okay. And the position is different from point to point. Okay. So basically, a body is said to be in motion. Is said to be in motion. What you said is also correct, literally, but in science we have to be very specific. Okay. So a body is said to be in motion when its position changes with respect to its surroundings with time. Okay, so this is when we say that the body is moving, right? So then what is rest? When do we say body is at rest? From the same definition. So when its position does not change with time. Simple. So in this case, the position of the body does not change with time. Okay? Does not change with respect to its surrounding with time. Now, is it possible for the body to be in motion and rest at the same time? No. What is it? Okay. So it depends. So basically, motion and rest are relative concepts. Okay. Motion and rest are relative concepts. It means that the body may be in motion. Body may be in motion or rest at the same time. Okay, it is a relative concept. Depending upon how its motion is observed. Okay, so I'll give you an example. Let us say there are two people sitting in a car. Right? So these are two people sitting in a car. Car is moving, and there is somebody standing on the pavement or footpath. Yeah. Car is moving on the road, and this person is standing on the footpath. So let's call them as A, B, and C. Okay, car is moving, whereas this person is standing. Now, what is the motion of B with respect to A? How will is A saying what is the position of B with respect to A? Is it changing with time or fixed? Huh? Is the position between A and B changing? No. दोनों के बीच में distance है, right? So B is at rest with respect to A, right? So B with respect to A is at rest. But when do we say that body is at rest? When its position is not changing with respect to from where it is being observed. Okay. So for B, so for A, B is at rest. Likewise, A with respect to B is also at rest. Correct? But what about A and B with respect to C? Are A, B moving? Okay. So although A and B are at rest with respect to each other, whereas C sees them that they are both moving. So A and B with respect to C are in motion. What is the status of C when you observe it? It is at rest. But how are A and B seeing C? Huh? A and B will feel that C is moving backwards. But is C moving? But it is appearing moving to A and B. So the body is at rest or in motion, okay, depending upon how the motion is being observed. It depends on the observation. That is why we say motion and rest is relative concept. Relative means it depends on how the motion is being observed. Is this clear? Write down the we'll now discuss some more terms which will help us understand motion in a better way. The concept of distance and displacement after this. So you should also write the date and lecture. What is the date today? 5th. So for every topic that is being discussed, till the topic is finished, the lecture count will increase. Okay, so maintain the lecture count topic wise. Okay, each hour is one lecture. So let us say if you have two lectures together, okay, 1 and 2, that is 2 hours. Each hour is one lecture. Can I erase this side? Yes. That was so sometimes I make spelling errors, so just correct it yourself. Like it should be respect. Okay, there may be some that you correct yourself. So with respect to, this is a full form. I mean acronym with respect to. WRT is with respect to. So you'll come across it many times. It's acronym for with respect to. Get this part? So let us understand whenever a body moves, obviously it covers some distance, right? So let us define what is distance and displacement. First complete right. Completed?
So we have to write that.
This one? Yeah, because this description is with respect to this one.
So we have to write this. We have to write this one.
Better for your understanding. Because it is always better to, understand things with the help of example. So for this example, this description makes sense. If you just write this without this, how will you know? So example, the diagram shows the scenario. Just make any like freehand diagram. No need to draw perfect. So that you just know what is A, B, and C. These are three people in different situations. That's it. So car is moving. So this arrow means car is in motion. Sorry. Ah. Yeah, this is do, like as above. Same. Rest as position of A is not changing for B, like that. So since it is dicto, it's called dicto. So I use a lot of shortcuts. You don't. Please check it fully. How studying के लिए standard? Huh? How do you think it's going to be doing ahead? More, okay, because it's going to be more practical, more engaging, more detailed. So you have studied all these things before. Now, the concept of displacement. Have you read it before? Displacement. Have you studied in this class or before? Which standard?
Means in school, this class.
In school, in science. So what did they teach you? What is displacement?
The distance between the initial position to the final position, the shortest distance.
Shortest distance. It is which standard it was?
9th standard in school.
That's what I'm telling you. This standard, right? Before 9,
No,
that's what I was. So displacement is introduced in this year.
yes.
How much you have completed? Motion. Okay. You have completed the full chapter in school?
No.
Not yet. Okay, done. Okay, let us describe the concept of distance and displacement. Have you done writing? So, what is distance? So first, again, let me give you an example. Let us say there are two locations. One is say Mumbai, and this is Pune. Right? To reach Pune from Mumbai, there could be many paths. Many paths. Okay. So one is the old Mumbai-Pune highway. So it's a very road which is very lots of turns, right? Because it passes through the hills. Have you gone to Pune? Anybody? Why not? So, but which road? Expressway or old Mumbai Pune? No idea. Okay. So now there's a new road also, which is called the expressway. So obviously, this is initial location or initial position. In terms of position, these are two different positions. So initial position. Initial position is the position from where which is the starting position. Okay, start of motion. And this is the final position, the destination. This is called final position or location. So let us say this is 150 kilometer, right? So distance is the actual path length covered. What is distance? This 150 kilometer is this entire path length. Distance is the actual path length covered by a body during the motion. Okay, this is the actual path length covered. So throughout the motion, is the body moving in same direction or different directions? Different direction. Obviously, if you draw the direction map, so east, west, north, south, this will be northeast, so on and so forth, right? This will be west of south, this will be southeast or southwest, whatever. This is northwest, northeast, northwest, southeast, southwest level. Okay, and there could be up and down, so there are so many references. So you see here the direction is here, like towards northeast, and this is towards north. Okay, so everywhere the direction is changing. It's not in the same direction. Right? So whenever we talk about distance, we don't bother about the direction. It is just the path length. Okay? So it has only the value 150 kilometers. It has no direction. Right? So that means during the motion, actual path and covered over here, irrespective of its direction. Okay. But now imagine you had a path like this. Like this. What about the direction in this case? Is it changing? So it has a fixed direction. Right? Will the length be more or less? Less, obviously. So in this case, let us say it is 120 kilometers. Just random 120 kilometers. Okay. Now this is shortest distance between Mumbai and Pune. Correct? And also in a given direction. So here you have value as well as direction. So direction is fixed now in this case. So such thing is called as displacement between 2 points. Okay. So this kind of a distance in a given direction, shortest distance in a given direction is called displacement. So displacement is the distance, shortest distance, important, the shortest distance so I'm writing during a motion covered by a body. It's motion. in a specific direction or fixed direction. Okay, so displacement has two features. It has a value and also direction, right? So it is 120 kilometers. What is the direction? What is the direction? Towards east. Okay, so either you can specify the direction like this. Okay, there is another way of specifying direction. So, for example, we are going to study about motion in a straight line. Okay, simple motion. So, we are only going to study about motion in a straight line. Also, very briefly, circular motion, but mostly we'll be studying motion in a straight line. Okay. So, for a motion in a straight line, what are the directions possible? Yeah, please. What are the directions possible for a motion in a straight line? Mumbai to Pune. In this case, Mumbai to Pune, or yes, only two directions are possible, right? Forward and backward. So if the body is moving in the forward direction, then we say it is positive. Forward direction is taken as positive, and the backward direction is taken as negative. Okay. So if I write plus 120 kilometer, right now what it is? Either I write plus 120 kilometer, or I will say 120 kilometer towards east, or 120 kilometer in the forward direction. Okay, this is how I can specify direction. So mostly we will make use of plus and minus sign. Is that clear? So what are the straight line motions possible? Motion in a straight line is also called as rectilinear motion. So examples of motion in a straight line. This is called rectilinear motion. Okay. So examples of motion in a straight line. Straight line motion is also called as rectilinear motion. So there are only two kinds of motion possible: horizontal and vertical. Yeah? So horizontal and vertical. So for horizontal motion, the positions are represented on a x-axis. Okay? Positions are represented on x-axis like this. So all these are different positions which will change with time. So vertical motion is horizontal and vertical. Vertical is represented on y-axis. Right? Like somebody drops a stone from a roof of the building. So you can take the roof as origin, or somebody throwing a stone above the building from the roof. Then this will be positive and this will be down. Upward is positive. So upward motion is positive and downward motion is negative. Likewise here, motion towards the right of origin is positive, and so forward motion is positive, backward motion is negative. Okay. Like if the motion is here also in this direction, then also it will be negative only. It's the direction. Okay, positive and negative sign is of the direction. Is that clear? So if you understand all this, then you will not make mistake in solving the variables. So write till here and then we'll go further. Very important concept. Okay, let me cover a few more things. So distance has only value, no direction. So value is also called magnitude. Okay, this is so it has magnitude only. Or value. So and whereas displacement has both magnitude and direction. So in physics, these are different types of physical quantities. Distance will be called as scalar quantity. Those quantities which has only magnitude, which can be described only by its value, they are called scalar quantity. So distance is a scalar quantity. Whereas displacement is vector quantity. Okay, so scalar quantity and vector quantities are two different types of physical quantity. Vector quantity can only be described when you properly know its magnitude as well as direction. Both knowledge is needed to describe a vector quantity. Whereas a scalar quantity can be described only by its magnitude. Okay? So, yes, so this is displacement. Displacement is example of vector quantity. Whereas this is distance. So the difference is clear. Right? Distance is a scalar quantity, displacement is vector quantity. Can you think of other quantities for its description? Like if I ask you, say time, will it be scalar quantity or vector quantity? Time. Is time a scalar quantity or vector quantity? Does time have any direction?
No, it is like
Does it have direction? Time. Then so it will be scalar quantity. Direction is the characteristic of vector quantity, not scalar quantity. What about mass? Scalar. Because mass is only kilogram. Does mass have direction? No. Temperature? Scalar. Okay. Volume? Scalar. So displacement is vector, right? What about force? Vector. है ना? क्योंकि force समझो हमने लगाया 10 न्यूटन. 10 Newton force in which direction? So such quantities which cannot be fully described just by its magnitude. Force is vector. Likewise, a velocity, acceleration, as we are going to study about all that. So velocity, acceleration, these are all vector quantities. Okay? So you have different types of quantities, scalar and vector. These two you remember. What else I was going to tell you? Okay. So what is the unit of distance? How will distance be measured? Distance is meter. SI unit. Okay. Unit is meter. Written in small n, right? What about displacement unit? This unit is also meter. Unit of displacement is also meter. Okay? Okay, right till here then I'll explain to you the other things. So these are concept notes for your understanding. When you prepare for exam, that's a different thing. Once you understand this, then you understand your book. Okay? So this will help you understand your book easily. These things are concept notes. Maybe you can write this description first and then draw the diagram. That will be better. Or if you draw the diagram, that also is okay. See whatever helps you. What is the black? This is root 1. This is one root and this is another root. Like I said, there could be different paths, different roads. So these are root. So root 2 is the example of displacement. So I always make mistake in the spelling. Okay, what is the correct spelling? RE. So be careful. Center, meter, everywhere I goof up. So please correct yourself. Both are pronounced the same way. That's the reason there is spelling. If you pronounce it differently, then there won't be scope for mistake. That's the weakness of English language. Like videos in Hindi, right? So what you pronounce is what you write. There's no scope for confusion. Right? Meter can be written only in one way in Hindi. There's no other. That is the strength of the linguistic strength. You should make different directions in this.
So, what if my initial position is Pune and final position is Mumbai? Then the what horizontal positive and negative exchange of
For distance, no difference.
means
distance
direction
remains-
only positive distance.
For distance, nothing changes. 150 kilometers. Pune to Mumbai. Okay, so distance is only 150 kilometers. Right? Irrespective, so whatever direction changing, you will make it. But for displacement, it will be towards west,
So the positive
and it will be negative. Negative.
remains the same.
Huh?
Means it remains the same.
Magnitude is same only. Distance is not changing. What is changing? Direction. When you are starting from Pune to Mumbai, is Mumbai going far or coming near? No, Mumbai is where it is. So what has changed is only the direction of travel. Correct? Yeah. So if you are calling Mumbai to Pune plus 120, then you have to call Pune to Mumbai minus 120, so that you know that you are traveling in the opposite direction. It will become clear. I am going to give you an example now. 4 or 5 examples, totally clear. Everybody, written the left side, right side is just the examples of horizontal and vertical. So, can you give me some examples of vertical motion from real life? One to I gave. Any object dropping from the roof. So, any object in free fall. Yes, launching of rocket. Very familiar. And that's a vertical motion.
So what about aeroplane?
Yes, that also. But this is aeroplane doesn't lift like that, like rocket. So aeroplane is going in a circular path like this. It takes off. This is the path. So it has not only it has combination of so many motions. It's not like rocket. Or motion of the lift in the buildings. What is the motion of the lift? Up and down. Okay. So this is the example of what we do. Plane motion will be like this. Take off, cruise, and land. So this is the motion in a plane. This is the motion in a line. है ना? If any body is moving in a circular path, circle is a two-dimensional object. So this is the straight line motion. Right? But if you start moving like this, and it is a motion in a plane, no more a straight line. Right? This is a motion in a plane. Or anybody moving in circle. The path, it depends on the path. If it is one-dimensional path, then it is straight line. The path is two-dimensional. Plane is a two-dimensional plane because it is a surface. There it is a two-dimensional motion. Okay. So these are more complicated motions. You will learn about it later. So example is motion of car in a straight line. This is the example of horizontal. What is the example of vertical motion? Motion of lift. Launching of rocket. Okay. So only the launching of rocket is a straight line motion, but after a while the rocket also goes in a slightly different path. Okay. Then freely falling object. Okay. So these are all motion in a straight line. We're going to learn about that. Okay. Now I'll give you some tasks which will help us understand distance and displacement even better. So whatever you have learned, okay, you have to apply all that. Let us say we have an object whose motion we have represented on a x-axis. So x-axis, it is representing distance covered in meter. So it's a number line. So I'll give you various motions. Let us say the starting of the motion is at origin and we are calling that position as A. Okay. So serial number. So I'll give you different motions. Let's say first motion is from A to B. So what is the distance covered when the body moves from A to B and what is the displacement? So distance is 20 meters. What about displacement? 20 meters. Is it correct? Distance displacement 20 meter. Have we described displacement fully? What do you do? Is any information missing in displacement? Positive. So it should be plus 20. Whenever you are specifying displacement, you have to also mention the direction. So I told you, if the body is moving in the positive direction, it will be in the right direction. Left to right is positive. And if it is going from right to left, then it is negative. So you have to maintain it. Okay. Now second. So now you have to A to C. Right? Third. A to C. Then from C it comes back to B. Fourth. A to C, then it returns back to A. Fifth. Goes from A to C. Then comes to A. So now write down distance and displacement for all the remaining motions. You have written down the right side. Tell me what will be A to C distance? 40 meter. The displacement plus 40. Now what is the distance for 3 third motion?
60.
How much?
60.
60. So A to B is 20, B to C is 20, so 40, and then another 20. So it is 60 because there is no effect of direction, right? Plus or minus is plus only. What about displacement?
Plus 20.
Plus 20. So this is basically plus 40 minus 20, which is plus 20 meter. This is what it is. So for the same motion, the distance and displacement value will be different. Okay. So displacement is the shortest distance between the final and initial location. In this case, the final location is B. So 20 minus 0. So this is plus 20. Either you find out final minus initial or full path. So this is plus 40 minus 20. That's all. So in fourth motion, what should it be?
80 meter.
Distance is 80 meters. Everybody is understanding? Our distance is 80 meters. Full path 40 plus 40. So distance may you take without bothering about the signs. Full path length has to be added. Actual path length. So it is 80 meters. Now here what will be displacement? 0 plus 40 minus 40. So this is 0. Okay, so displacement can be 0. Has motion taken place? Yes. So if the body returns to the same location from where it started the motion, then its displacement will be called 0. Yes, any question? Now tell me here. 100. 40 plus 20 is 100 meter, correct? What about displacement?
-20.
Minus 20. So this is plus 40 minus 40 plus 20 minus 60. Minus 20. So this should be very, very clear in your head that what is the difference between distance and displacement. So what conclusion do you draw from this exercise? Displacement can be positive, negative, or zero. Right? So displacement can be so for a given motion, or zero. Motion is taking place, but displacement can have any values, positive, negative, or zero. Distance is always greater than zero. For a given motion. Okay, so in all 5 cases the motion is same, but distance value and displacement values may be same or may be different. Right? When distance and displacement are same. First 2 occasions. Distance and displacement is same when the motion is taking place in a straight line without change of direction. In that situation, distance and displacement becomes same. Okay? So these are the features. Distance and displacement are same when a body moves in a straight line without change of direction. Very important. And last, displacement is always less than or equal to distance, but never more. Okay? So you can just write this point yourself. Displacement is always less than or equal to distance. All right. We will visit in the next.